Hi, welcome to the next topic in the section on measurement. It's called surface area of prisms and cylinders. Oh, surface area. Okay, we better look at that. We come over here and surface area, the area of all the surfaces. Hey, what do you notice? We've gone into three-dimensional figures here. They've got length and breadth and depth. They're a three-dimensional figure. And so the surface area is the area of each of the surfaces that make up this 3D shape. So there'd be those, and then there's one in the back there, one on the side, hey, one down the bottom. If you were going to paint this box with a shape, you would need to know the surface area of all those. Perhaps not the bottom, you might not paint the bottom, but you'd want to know the area. So that's what we're going to do. We're going to be working with 3D shapes, and the ones that we're dealing with here now are going to be cylinders and prisms. Now I guess most people know what a cylinder looks like. It's sort of like that. It's got a circular end and then sort of stretched out. And then prisms are these other ones here. So we're going to have a look at these, and this is a very practical unit of work in mathematics, so it should excite you. I mean, there is some theoretical stuff at this level which hasn't got any obvious application to you, but this one has, so let's have some fun with it. And come on down and let's work with some screen clippings here from Pearsons' textbook, which would be handy if you had that close by there, do some reading for yourself. So a prism is a solid, so we just said that. It's a solid, so it's a 3D shape with straight edges and uniform cross-section. What does that mean? Well, here's their interpretation. The shape on the end continues all the way through to the other end, but the word actually comes in two parts. Uniform meaning the same all the way, and cross-section, sectioning or cutting across. Sectioning equals cutting across. Cross-section, cutting and across for cross-section. So what does that mean? Well, let's come over to this one over here. If that's the end, if I cut through here anywhere through the body going that way, I will produce this end shape. So that's called the cross-section. The common section or appearance I get cutting across the body. Where would I have to cut this one to get a common cross section? If I cut parallel there, anywhere through the body going that way, I would produce this triangular shape. So that's its cross section. And that would be called, this would be a rectangular prism. Rectangular prism, a triangular prism, because the cross section is a rectangle or a triangle. What about this one over here? It's a little bit different. Here, where will I cut? Well, I couldn't cut this way, could I? Because it's getting bigger and bigger as I go up, so I have to give that a miss. But if I cut this way again, through here, each time, sectioned it through, sectioning, dissection, cutting into two or something like that, then the shape I would get would always be this one, right the way through that way. So what would you call this? Well, this is really a trapezium, isn't it, on the end here, a trapezoidal prism. We don't worry too much if the shape changes like that, but you could call that a trapezoidal prism. All right, well, what are we about? We're about finding the total surface area. So we're going to try and work out what all of those shapes are. Now, this one's a bit different, and there's one on the back, don't forget the end, and on the bottom. So let's go and have a look at some of these now and see what we can make of it. Here's the first example from Pearsons. So here's our problem. It's not a bad idea to make up a net. A net is, if you like, those shapes that capture the body. So you think about laying this out that way, that way, that way. And if you do, you get these shapes here. It's all laid out. So it's like, what would you do to make that shape? You'd fold it all up. So we need to find some lengths here, I guess, before we go on, because the only one that you can actually work out is this one on the end, which is 6 by 6. So you can work that one out, but over here, if you look at it, we only know that length, and we because this is equal here, that's a 6 as well. So we've got a 6 there. So I'd like you to bring this triangle down like that and put 8 and 6 and X. And this one's going to be identical. So just notice there, you've got to pinch the 6 there because it's the height up here, which is 6 by 6 in that one. So then you put Pythagoras in brackets. So it's not a bad idea to extract the triangle from the net that you're working with and then work it out. And just coming down a bit then, the surface area, you can go through each of these. So it's A1 plus A2, which is this one here, and there's 2 lots of A3 because the top and bottom triangles were the same, plus A4. And then we've got to go through, again as before, putting down the formulas for each of those. Notice we've got 2 rectangles, so half base times height cancels to just base times height. And then putting the numbers in, going through and making sure you have all the numbers. So the 8, we've got the 8 there, so that's all right. 6 squared there is okay. 8 by 6, yep, because that was a 6. And then another 8 by 6 down the end here. And then, sorry, a 10 by 6 down the end, and we got the 8 by 6 as the 2 triangles. So how did we get this one here down the bottom there? That was our 10 by 6, A4. How did we get our 10 by 6? Well, this is, back up here, X is 10. So that was our X in there as well, wasn't it? Because when that was folded over, that was the same length as that. So our X was 10. And we can use it there. So got to be a little bit tricky-dicky there, and then add them all up and work it out. So really the problem amounts to how to find the missing lengths. Okay. Do you get it? Go back, have another look, and see if you can put it all together. I think the net idea to lay out the shapes and see their connections is the important one. Let's go down and do another little bit of work on cylinders. Now, a cylinder is, I suppose, a circular prism, isn't it? Because it's got uniform cross-section. We're cutting it through. Let's have a look at that. Well, we don't call it a prism in actual fact. It's got its special name, cylinder. So here we go. If we cut it through this way, parallel to the base or the top, you'll always produce a circle. That's the idea of a cylinder. So here we have a cylinder broken up into its net. So you've got a top of the cylinder and a bottom, although sometimes they might be open at the top, so I only have one. And then the curved surface is the interesting part. If I was to cut this up here, let's take a pair of scissors and cut it up here and lay it out, how long would it be? Well, that would be its circumference, wouldn't it? Because it came from a circular shape. And when I laid that out, when I cut it up here and laid it out, it was that long and that tall. So that becomes a length by the breadth now. So what have we got? We got 2 circles, top and bottom, plus the curved surface. Okay, so you could put that surface area is area of 2 circles plus area of curved surface. You can put that, or draw the picture and put A1, A2, etc. And so coming back over here, you've got 2 lots of circle, and the curved surface is the circumference laid out to make a rectangle times the height. So you could factorise the formula of that, or just substitute the numbers in at this stage. You don't need to do too much of this mathematics here, because generally we would show that in every problem, not just memorise the formula. Actually show the two pieces. That is, say, for later in maths where they want you to explain your whole solution, not just perhaps plop in a formula. Don't memorise this formula. It doesn't help later on. Okay. All right. Are you ready to do a bit? I think you should take a break. I found these couple of cylinders. I bought some lunch for you here. You're going to get pretty hungry. Pea soup and pork and beef over here. You can take your pick. Actually, I hope I got them cheaply because they look like pretty old-fashioned cans. Anyway, take a break if you need it, but we're going to move on now. Here we have another cylinder type example, and so here we have just a straight one. The important thing here is the surface area is, of course, 2 times the area of the end plus 2 pi rh. Just remembering now, what's the 2 pi rh? If I cut it up there and laid it out, how long would the rectangle be? It'd be a circumference's worth stretched out times the height. So that's that formula there. And then the radius, make sure when they give it to you that you don't use the whole diameter. Here they've given the radius. They'll give you the whole diameter. Don't forget to halve it to get the radius. And then the height. And then just showing the substitution in and rounding off. They ask for 2 decimal places here, which is not usual. It's usually 3 significant figures or to the nearest squarest centimetre, something like that. Okay, I think you've had your cans of soup and the beans and stuff, so let's do some work. Okay, here are the formulas we're going to summarise. We'll just go back up here. So here, formulas for surface areas of prisms and cylinders. I wouldn't memorise these formulas here. I'd be able to work them out. I would show the working each time, show the working, this sort of thing here, so that you are more or less giving a complete solution. Don't memorise the fully factorised form and so on. Be able to show it, okay, in stages. All right. I mean, you can use this 2 pi rh. You don't have to show that and this, but I wouldn't go to the factorised form. All right. Okay, let's work. Here are your problems. This is for the first section. Question 1, I've got the solutions down the right-hand side. I think do most of these. Question 1 and 2. Pause the presentation, have a go. Let's go on. Question 3 there. And see if you can work out what's actually going on there rather than guess a solution. Question 4 and 5. Think about those. They're fairly basic shapes. This one's an interesting one. Read that carefully. And then in our reasoning section we've only got the one question. Question 6. A fair bit of work there. You might have to think about this because you'll be subtracting some areas away from other areas there. And the open-ended question, question 7. Just remember there are only sample answers because there's various ways you can do that. All right, are you getting excited? You're doing some useful stuff here, so let's build up the skills and have a go. Now we're going to come back and develop this area of measurement a bit later on. So I hope to catch you in the next presentation. But for the moment, it's cheers from me.